Okay, we're just going to continue doing more examples with partial fractions just to see how this stuff works out. So in this case, I'm going to have 4x plus 1 over x cubed minus 3x squared minus 4x. Let's see, I can factor an x out. So that's going to give me x times x squared minus 3x minus 4. Then x squared minus 3x minus 4, that's going to be what? X minus 4 times x plus 1. So my 4x squared plus 1 over x times x minus 4 times x plus 1. The things that have a common denominator for this is a over x plus b over x minus 4 plus c over x plus 1. By the way, in the examples that follow, I'm not going to spend a lot of time factoring these things. I'm going to assume you know how to factor them. So I'm not going to waste time on that. So now if I multiply both sides by this denominator, I get the numerator, which is 4x squared plus 1. Oops, on the right, I have a over x plus b over x minus 4 plus c over x plus 1. All times this denominator, which is x times x minus 4 times x plus 1. So left-hand side is still 4x squared plus 1. When I multiply this through, the x's cancel, so I get x times x minus 4 times x plus 1. For the second term, the x minus 4 terms cancel, so I get bx times x plus 1 plus c. Now here the x plus 1's cancel, so I'm left with x and x minus 4. Let's do this. Let's get rid of x and c first. So let's let x equal 0. So I get 4 times 0 squared plus 1 equals a times 0 minus 4 times 0 plus 1 is minus 4a. So 1 equals minus 4a. A is minus 1/4. Now I want to get rid of the a and the c, so I'm going to let x equal 4. If I do that, I get 4 times 4 squared plus 1 is a times 4 minus 4 times 4 plus 1 plus b times 4 plus 1 c times 4 minus 4. 16 to 64, 65. It's going to be 0. It's going to be 5 times 4 is 20b. That's going to be 0. So b is 65/20. Okay, and now, so I've got a, I've got b, so let's let x equal minus 1. That'll leave c. If I do that, I get 4 times minus 1 squared plus 1. I get a times minus 1 minus 4 times minus 1 plus 1 plus b times minus 1 plus 1 plus c times minus 1 minus 4. Whew. So 4 times 1 plus 1 is 5. This is going to be 0, 0. So this is minus 5 times minus 1 is 5. So c equals 1. And yeah, okay. Sorry, just double checking. So 4x squared plus 1 over x cubed minus 3x squared minus 4x is a over x. That's minus 1/4 over x. B is 65/20 over x minus 4. And c is 1 over x plus 1. And again, I would much rather work with this expanded thing on the right than this rather awkward looking thing on the left. Another example. Let's look at 2x squared plus 3x minus 2 over x cubed minus 3x plus 2. Okay, again, it's assumed you've done this in Calc 2 and you can go through and do this. So I'm not going to go through all the details here just for time. If you factor this denominator, you should get x minus 1 squared times x plus 2. Right. If you notice, if you let x equals 1, you get 0. So you should immediately see that you can factor out an x minus 1 and go from there. All right. Having said that, I get 2x squared over 3x minus 2 over x minus 1 squared times x plus 2. Of all the things that could have this common denominator, I have to consider that that is a over x minus 1 is in there, right? Because its common denominator is going to have an x minus 1 squared when I bring it together with b over x minus 1 squared. And then that's going to leave the c over x plus 2. Okay. Of all the functions that have this as a common denominator, those are the possibilities. So if I multiply both sides by the denominator, I get the numerator, 2x squared plus 3x minus 2. On the right-hand side, I've got a over x minus 1 times b over x minus 1 squared plus c over x plus 2. But I have to multiply by this denominator, x minus 1 squared times x plus 2. Multiplying that through, I get the left-hand side, 2x squared plus 3x minus 2. A over x minus 1 times x minus 1 squared times x plus 2. One of the x minus 1 terms is going to cancel, so I get a times x minus 1 times x plus 2. When I multiply b over x minus 1 squared times x minus 1 squared, those two cancel, and I'm just left with b times x plus 2. Finally, if I take c over x plus 2 times x minus 1 squared times x plus 2 squared, x minus 1 squared times x plus 2, the x plus 2 terms cancel, and I get c times x minus 1 squared. Let's do this. Let me isolate b first. So let me let x equal 1. If I do that, I'm going to get 2 times 1 squared plus 3 times 1 minus 2 on the left-hand side. This term will be 0 because I'll have 1 minus 1. This will be b times 1 plus 2, and then the c times x minus 1 squared will be 0 because x equals 1. So I'm going to have 2 plus 3 is 5, minus 2 is 3. It's equal to 3b, so b equals 1. Let's get rid of the b now by letting x equal minus 2. If I do that, I'll get 2 times minus 2 squared plus 3 times minus 2 on the left. If I let x equals minus 2, the a term will go away. The b term will be 0. I'm left with c times minus 2 minus 1 squared. So this becomes 4 times 2 is 8. Minus 6 minus 2 is going to be 9c. So 0 equals 9c, so c equals 0. Didn't see that coming. And so this means that x plus 2 must factor out the numerator. That's okay. It doesn't matter. I'm just going to arbitrarily let x equals 0 on the left because that tends to be nice. Sometimes it's not. So I'm going to get 2 times 0 squared plus 3 times 0 minus 2. And then in this expression, I'm going to get a times minus 1 times 0 plus 2 plus t times 0 plus 2 plus c times minus 1 squared. So I get minus 2. So I get minus 2a plus 2b, but b is 1, so that's going to be plus 2. C is 0, so that goes away. So now if I subtract 2 from both sides, I get minus 4 is minus 2a, so a equals 2. So my original expression, 2x squared plus 3x minus 2 over x cubed minus 3x plus 2 is a over x minus 1, so that's 2 over x minus 1, plus b, which is 1 over x minus 1 squared, and then the c is 0, so that's all I have left. Now, you may be asking, did I really need this? And the answer is yes, because I did not know in advance that that was going to cancel with that numerator. So unfortunately, you have to consider all the options. Sometimes your options just don't work. By the way, if you go through and you work all this out and you get something that doesn't make sense, that's fine. That just means you made a mistake and you got to try something else. Okay, try that again. Suppose I have x plus 3 for x squared plus x plus 4 minus 1 over x minus 2. The key thing here is to recognize the polynomial degree of the top is less than the polynomial degree of the bottom. And also, I cannot factor this denominator without using complex numbers, and I don't want to get into that right now. So just as before, my common denominator is going to be the product of the two denominators. So the first term is x plus 3 over x squared plus x plus 4. If I multiply by the denominator of the second term, which is x minus 2, I have to multiply that by the top and the bottom. And then the second term looks like 1 over x minus 2. And the denominator of the other term is x squared plus x plus 4. So I got to multiply top and bottom by that term. So now when I expand everything out, this numerator here becomes x squared plus x minus 6. I'm going to have the x squared plus x plus 4 over x minus 2. Then I'm going to subtract, and then here I just have the x squared plus x plus 4. Now, notice the x squareds cancel, the x canceled. I'm left with minus 10 over x squared plus x plus 4 times x minus 2. So what does that mean? That means if I start off with minus 10 over x squared plus x plus 4 times x minus 2, I'm going to have something over x minus 2 plus something over x squared plus x plus 4. I have to consider all polynomials of degree less than 1 for this, but that is just a constant. Here I have a polynomial of degree 2, so I have to consider all polynomials of degree less than 2. So I'm going to have bx plus c there. Okay, fine. I'm going to just proceed exactly as I did before. I'm going to multiply both sides by the denominator. So I get minus 10. On the right, I've got my a over x minus 2 plus bx plus c over x squared plus x plus 4 times x squared plus x plus 4 times x minus 2. Leave the left-hand side alone. Now, a over x minus 2, when I multiply by x squared plus x plus 4 times x minus 2, the x minus 2's cancel. So I'm just left with x squared plus x plus 4. The second term is bx plus c, but now it's over x squared plus x plus 4. That's going to cancel with the x squared plus x plus 4, leaving x minus 2. Notice if I let x equals 2, that term will cancel, and I can just focus on a. Left-hand side is minus 10. So here I'm going to get 2 squared plus 2 plus 4. 2 minus 2 is 0, so I'm just left with that. So that's going to be 4 plus 4 is 8. I get 10a So a is minus 1. Okay, so now, notice now I've got, I'm just going to do it this way. I'm just going to say let x equal 0. I'll get minus 10. I now know a is minus 1. So now I'm going to have 0 plus 4. I'm going to have b times 0 is 0 plus c times 0 minus 2. So I get minus 10 is equal to minus 4 minus 2c. Add 4, so I get minus 6 is minus 2c, and c is 3. Finally, let's see. I'm after b, right? So a is minus 1, so that's minus x squared minus x minus 4. And if I expand this out, I'm going to get bx squared plus cx minus 2bx. Oops, let me be careful here. Bx squared plus cx. I'm going to get minus 2bx minus 2c. So this is minus x squared minus x minus 4 plus bx squared. Now c is 3, so I'm going to have 3 minus 2bx minus 6. There are no x squared terms on the left, so those things have to cancel out, which means b has to be 1. I can do a quick check here. If b is 1, this is going to be 3 minus 2. This is 1x minus x plus x is 0. There's no x's on the right, so that checks. And then the constants should be minus 10. Minus 4 minus 6 is minus 10. That checks. So all of this means that my original expression, minus 10 over x squared plus x plus 4 times x minus 2, is equal to a, which is minus 1 over x minus 2, plus bx plus c, so that's x plus 3 over x squared plus x plus 4. And again, in some circumstances, this thing on the left is really hard to work with, but the thing on the right is still going to be hard to work with, but it'll be easier to work with. All right, just in general, if you have things you're expected to be able to do is if you see something like this, you're expected to be able to factor this and figure out that it should look something like this. And its general form then is going to be a over x plus bx plus c all over x squared minus x plus 1. If you see something that looks like 5 over x squared plus 4 times x squared minus x plus 10, you should recognize that the first term is going to be ax over b over x squared plus 4, and the second term is going to be cx plus d over x squared minus x plus 10. If you see something that looks like 18 over x minus 1 times x plus 2 times x plus 3, you should recognize that's going to be a over x minus 1 plus b over x plus 2 plus c over x plus 3. If you see something that looks like 4 over x squared times 3x plus 2, you should be able to factor this to a over x plus b over x squared plus c over, okay, I can't factor that without complex numbers. So that's going to be cx plus d over 3x squared plus 2. However, if it's 4 over x squared times 3x squared minus 2, you should be able to factor that denominator and get a over x plus b over x squared plus c over, so that's going to be, x minus square root of 2/3, is that right? Yeah, it'll give me the 0 plus d over x plus square root of 2/3. Like so. Notice now there's a factor of 3 here, but because of the c and d are constants, that's going to come out of the wash.